Japan is one of the most disaster-prone countries in the world, with various disasters occurring frequently due to geographical conditions, climate change, and change in the social environment. As the risk of national catastrophic crises are increasing, maximizing efforts to strengthen the country's disaster resilience is an urgent task. National Research Institute for Earth Science and Disaster Resilience was established in 1963 in the wake of the Ise-1 typhoon. In all phases of disaster prediction, prevention, emergency response, and recovery reconstruction, NIED has been engaged in research and development of disaster risk reduction science and technology as the only comprehensive national research and development agency for disaster risk reduction, and has challenged the development of science for resilience to protect human lives and society from natural hazards. NIED is a core research institute for disaster risk reduction science and technology in Japan, operating one of the world's largest experimental facilities in an observation network covering the entire country. E-Defense is an earthquake testing facility equipped with the world's largest 3D shake table. The table can carry full-scale structures weighing up to 1,200 tons. It precisely simulates strong ground motion, such as the Kobe earthquake in 1995, and it is used to evaluate the seismic performance of structures and verify business continuity. The large-scale rainfall simulator can reproduce rainfall of up to 300 millimeters per hour and is used to conduct research into landslides, debris flow, flooding, and other water-related hazards. The Cryospheric Environment Simulator is the only experimental facility in the world capable of reproducing near-natural snow throughout the year. It aims to bring clarity to snow and ice phenomena and verify the effectiveness of disaster countermeasures regarding roof snow, snow accretion, blizzards, and avalanches. Monitoring of waves on land and sea floor, called MOLAS, is the fundamental observation network composed of observation stations installed on land and ocean floor throughout Japan. The purpose of MOLAS is to provide comprehensive, accurate, and rapid observation and monitoring of earthquake, tsunami, and volcano events across Japan and its offshore areas. In preparation for a megathrust earthquake that is expected to occur in the near future, Nankai Trough Seafloor Observation Network for Earthquake and Tsunamis, NNET, is scheduled to begin operation in 2025.
MOLAS retrieves observation data from approximately 2,100 observation stations, and it is used for both basic research and disaster mitigation. MOLAS data can be processed in real time and continuously monitored on the Kyoshi monitor, which visualizes and live streams current ground shaking in Japan. We provide an essential data for the earthquake early warning and tsunami warning system operated by the Japan Meteorological Agency.
In Japan, there are 111 active volcanoes, many of which pose risks due to future eruption. To strengthen efforts in volcanological research and its practical application to volcanic hazard mitigation, the Japan Volcanological Data Network was formed in 2019. JVDN is the only system in Japan for sharing volcanological data, which serves as a platform that combines observation, forecast, and countermeasure data. For example, immediately after an eruption, we can quickly input and share data on volcanic ash transport and dispersion.
At the Storm Flood and Landslide Research Division at NIED, I'm looking into the engineering application of rainfall data. Our approach involves examining historical rainfall data and disaster records to establish a link between the variability of rainfall events at a particular location during a certain period and how that may affect the risk of weather-related disasters all over Japan. If we can find the high-risk area before the occurrence of a possible disaster, then we can concentrate more effort on the area so that we can mitigate disasters effectively.
As the Center for Comprehensive Management of Disaster Information, we focused on the use of satellite data and web-based information sharing platform to support decision-making and situational awareness during all phases of disaster management. In October 2019, Typhoon Hagibis made landfall in Japan, causing widespread flooding. Using satellite observation, we extracted GIS data of flooded areas and superimposed them with building data to estimate the number of flooded buildings by municipality. The results were published on our crisis response site and shared to disaster response organizations. Based on these practices, we plan to build a system that automatically aggregate and generate information related to each respective disaster.
Our organization, NIED, is a national research and development agency. So, I believe we are in a position to lead the country's disaster risk reduction efforts as a national center. We would like to work with various research institutes, including universities, etc., to solidify nationwide actions and take international leadership. Our mission is to realize human and social security by combining scientific knowledge and technology from all fields and conduct comprehensive research that links observation, experiment, prediction, information, recovery, restoration, and society.
In Japan, mega earthquakes are anticipated to occur in the near future. Meteorological hazards are exacerbated by climate change and pose a major threat to sustainable development worldwide. The importance of disaster resilience is more significant than ever. We are deliberating how science and technology for disaster risk reduction should be to protect lives and livelihoods. NIED will continue to promote research and development towards the realization of a society resilient to disasters.